Welcome to another episode by MedEasy-Forum. You know, your body is basically a fortress, and it is under constant siege from everything. But here's the really cool part. Long before you even feel a tiny symptom, an ancient, super powerful defense system is already at war for you. Today, we're going to explore that incredible first line of defense, your innate immunity. So think about it. Before you even get that first scratch in your throat or a little sniffle, this ancient security force has already engaged the enemy. What is it? Well, that silent, 24/7 guardian is your innate immune system. All right, so here's the core concept. The two words you really need to remember here are immediate and nonspecific. This isn't some highly trained sniper, this is the frontline infantry. It's the system you're literally born with, and it's pre-programmed to recognize general danger signals and react with lightning speed.
To really get a handle on how it works, let's use an analogy. Let's imagine your body is a fortress. Now, what's the best way to defend a fortress? Right, you stop the invaders from ever getting inside in the first place. And that is exactly what our first line of defense does.
This first line is really made up of 3 layers. First, you've got your physical barriers. Your skin and mucous membranes. They're literally the high stone walls of the fortress. Simple, but so effective. Then you've got chemical barriers, which are kind of like fiery moats. We're talking about the super intense acid in your stomach or the pathogen-destroying enzymes right in your tears. And finally, and this is wild, there's a biological barrier, the trillions of helpful bacteria living on and in you. They're like the loyal citizens of the fortress, taking up all the prime real estate so hostile invaders have nowhere to set up shop.
But what happens if an invader actually breaches those walls? Well, that's when the patrols spring into action. These are the cellular soldiers that are constantly on guard inside your body. Now, I love this slide because each cell basically has a job title. You've got neutrophils, the heroic first responders who just rush to the scene. Then there are macrophages, the big eaters, and they don't just fight, they clean up the whole mess afterwards. You have natural killer cells, or NK cells. They're the internal security guards, dealing with threats from the inside. And mast cells, they're the alarm ringers, letting everyone know, hey, we've got a problem over here. So let's look a little closer at our 2 main eater cells. Neutrophils are the shock troops. They arrive incredibly fast, they engulf bacteria, and then they die in the process. They literally fight to the death, and that collection of dead hero cells is actually what we know as pus. Macrophages, on the other hand, are a bit more methodical. They're long-lived, they hang out in our tissues, and they act as the official cleanup crew, devouring pathogens, cellular debris, and even those dead neutrophils. You absolutely need both for a successful defense. And this right here, this is one of the most critical jobs in the entire fortress. See, NK cells don't hunt for outside bacteria. Instead, they patrol for traitors, your very own cells that have been hijacked by a virus or have become cancerous. When they find one, they don't just attack it, they actually order it to self-destruct. This is huge because it stops the threat from spreading from within.
Okay, so we've got the walls, we've got the soldiers, but how do they all coordinate? How do they talk to each other? Well, they use a fortress-wide alarm system, and this is known as the humoral response, which just refers to all the important stuff found in the body's fluids, or humors, that help sound that alarm. Now, this alarm system has 2 really key parts. First, you've got the complement system. This is a whole team of proteins that can directly attack invaders by punching holes in them. Or they can act like a flare gun, tagging a pathogen to make it an obvious target for other cells. Then you have cytokines. Think of these as the chemical messengers that spread out like a signal flare, basically shouting, "Hey everybody, the fight is over here, get here now!" Now this innate system is amazing. It really is. But sometimes it faces an enemy that's just too powerful, or maybe too sneaky. And when that happens, it knows it needs to call in the specialists, the highly trained elite forces of what we call the adaptive immune system. This crucial handoff is performed by a very special kind of scout, the dendritic cell. What it does is so cool. It captures the enemy right there at the infection site, then it travels to a lymph node, which is basically the military command center, the war room, and it presents a piece of the invader to the elite T cells. This little piece, it's called an antigen, and you can think of it like the enemy's uniform. This handshake is the intelligence briefing. It tells the elite guard exactly what the enemy looks like so they can launch a highly specific, targeted counterattack.
So to wrap it all up, let's just go over the innate system's rules of engagement one more time. First, it is incredibly fast, launching a defense in just minutes. Second, it's non-specific. That means it's looking for broad patterns that are common to lots of germs, not the unique signature of one specific virus. And third, and this is critical, it has no memory.
it'll fight the same invader with the exact same strategy every single time, unlike the adaptive system, which actually learns and remembers its enemies. So, the first responders have held the line. They've contained the threat. But what's next? The answer to that question is both. You see, those secret messages, the cytokines we talked about, they're the very things that create the fiery heat of inflammation. It's that familiar, red, swollen feeling, and it's the ultimate sign that your fortress defenses are working exactly as they should. The innate system is truly the unsung hero of our health, and we'll explore that fiery battleground of inflammation next time.